Hello everyone, welcome back to the channel. In today's video, we will going to create a cool RGB shader for this case fan. It will look something like this at the end. For this, I am using Unity version 2022.2, but it will work on any Unity LTS versions. I have a project in URP. I also have this cool case fan model, which you can download from the link in the description. When you import it in your project, go to Import Settings under Models tab, uncheck Convert Units and check Bake Access Conversion. Our fan has 3 separate game objects. I have applied URP lit material for base and this holder, and we will use shader graph for the actual fan mesh. Then I have the post-processing volume with the modules bloom and tone mapping with the mode ACES. Now with that out of the way, let me roll the intro. We can break down the effect in 2 simple steps. First, gradient color with full color spectrum, and second, the rotation. Let me first create a shader graph. Right click, create, shader graph, URP and lit shader graph. Let's call it RGB shader graph. We will also create a material, so select our shader graph, right click, create, material, and call it RGB case fan and assign it to our fan. In our shader graph, let's deal with color part first. We want a full color spectrum, so we can just take a color and shift its hue values to get the spectrum. Let's create a color node. Set the mode HDR. Assign a default color. I'm setting a red, but you can set color of your liking. Then we will take its output and feed it into hue node. It will shift this color's hue by this offset. Set the range to normalized. By setting that, we can get all colors with value range from 0 to 1. And the offset that we feed will be normalized, so if I feed 20.5, it will be considered as 0.5. Now to get the spectrum, we can use UV node. Split it. And now we can take either X or Y to get the spectrum. We want the spectrum that goes around instead of this flat one. For that, we can use polar coordinate nodes. In polar coordinates, X goes outward and Y goes around. So X has 0 in the center and then it goes outward. Y has -1 here, then it goes around, has 0 here, then again 1 here. Center is pretty self-explanatory. Now this radial scale and length scale, think of them as a tiling of X and Y respectively. Now polar coordinate has exact same UVs as our UV node, so we will delete them and take our polar coordinates output and feed it into the split node. We want spectrum that goes around, so we will take Y and feed it into the offset. We want to control the intensity, so let's create a float property. Call it intensity. Give a default value of 1, drag it in, and we will multiply our spectrum with the intensity. Then take our multiply node's output and feed it into the emission block. In scene view, we have this nice color spectrum that goes around, but it covers the entire fan. I want to leave out the center. To do that, we will mask the center. For that, let's create ellipse node. It will give us this nice little circle. We can control its radius with this width and height. We will control it from the inspector, so let's create a float property. Call it mask radius. Give a default value of 0.3. Set the mode to slider with the range 0 to 1. Drag it in and feed it to both width and height. Now we want to mask this circle, so let's invert it using 1- node. 1- node will subtract whatever value we feed in from 1. In our case, it will invert the values. We will multiply these two together. Then we will take this multiply node's output and feed it into emission block. We will also create a color property for base color so we can access it from the inspector. Drag it in and feed it into the base color block. Our gradient part is done. Now let's deal with the rotation. We can create a script for that, but since we are not dealing with collision, in fact our fan is only aesthetics, so I want to deal with rotation in our shader itself. Why, I hear you ask? Because every mono behavior script will run on CPU, and since we are not dealing with any gameplay logic, it is a good idea to offload this work on GPU. That is the reason compute shaders are very popular. Okay, back to rotation. We want to rotate this fan around Z-axis. In our shader graph, let's create a position node. It gives us each and every vertex position. Let's set the space to object, because we will rotate our fan locally, so it won't mess up if we rotate the parent game object. Then we will take its output and feed it into rotate about axis node. It will rotate this input around this axis about this rotation. We want to rotate around Z, and Z axis will always going to be 0, 0 and 1. Now we will rotate it over time, so let's create a time node. We want to control the rotation speed from the inspector, so you guessed it, let's create another float property. Call it speed with default value of 1. Drag it in. Now we will take our time and multiply it with our speed. Then take this multiply node's output and feed it into the rotation. Lastly, take our rotate about axis node's output and feed it into vertex context position block. Now our fan is rotating in the wrong direction. Also, our colors are rotating with the fan. So let's fix that. To rotate our fan in opposite direction, we will just change this axis to 0, 0, -1. Then to keep the colors in place, let's rotate them in opposite direction of our fan. For that, let's take this multiply node's output and feed it into negate node. It will multiply whatever value we feed in with -1. Then to rotate our UVs, let's create a rotate node. Take negate node's output and feed it into the rotation. Finally, feed our rotate node's output to polar coordinate node's UV. That's all. Our shader graph will look something like this at the end. Save our shader. Head back to the scene view, adjust our material, and we have nice RGB fan. That's pretty much the video. If you find the video helpful, consider like, share and subscribe. If you have any questions, post them in the comments. That's it from me, and I will see you guys in the next one.